study the practice set 1.2. But before that, you have to clear your all basic concepts related to converse of BPT and angle bisector theorem. So that watch my previous videos whose links I have given in description box. So we'll start the practice set 1.2. Practice set 1.2. First example, they have given some figures and we have to identify in this figure ray PM. This ray PM, is it an angle bisector of that QPR? Now to prove it, this is the angle bisector. Angle bisector of this angle. Here I have to use the concept of the converse of angle bisector theorem. Now for the converse of angle bisector theorem, I have to prove it that QP upon PR. If it is angle bisector, then QP and PR's ratios is equal to the ratio of QM upon MR. Say that by converse of angle bisector, PM would be the angle bisector of that angle P. So we'll study. So to prove it, I'll take the ratio QP here, QP upon PR. What is QP? QP is 7 and PR is 3. If I reduce it by 2, if I make them half, then here it would be 3.5 and here it would be 1.5. Now the another ratio QM upon MR. So in this 3.5 and M is 1.5. This is first, this one is the second. From 1 and 2, QP upon PR is equal to QM upon MR. By converse of angle bisector, I can say that PM is a bisector of a angle P. That you have to write it here. And if you rotate this figure, it would be easy to understand it. So rotate means here instead of this, if I write in this way, P would be here and M here, Q and R, then you can get the ratio QP upon PR and here QM upon MR. So in this way I have proved the first example. We'll go for the next figure. Second figure, in this if you again write the figure in this way, then you will understand P is here, Q and R, here it is M. So RM is 6, here 8 and here RP is 7 and this 10. So again I'll take the ratio PR upon PQ. PR upon PQ. If I have taken PR upon PQ, that means I have to take RM upon MR. So RM upon MQ. Sorry. So PR upon PQ. What is PR? PR is 7. What is PQ? PQ is 10. Here RM is 6 and if here you can get it 8. If you reduce it, you will get the answer 2 3 are 2 4 are 3 upon 4. So these two ratios are not equal. So you can say that PM is not a ray PM is not a bisector of this angle RPQ. Next figure. Again, if I want to show that PM is a bisector, I'll take the PQ upon PR. What is PQ? 9 upon 10. This is the first one. Then if I have taken PQ, then I have to take QM upon MR. QM upon MR is equal to 3.6 upon 4. Here I have to take the ratio QM upon MR is equal to 3.6 upon 4. This is divisible by 4. If I reduce it, so I'll get 0.9. For 4 9s are 36 and here 4 1s are. And if I remove the decimal point, I'll get 9 upon 10. This is the second example. So from 1 and 2, I can say that PQ upon PR is equal to Qm upon Mr. So by the converse of, therefore, by converse of angle bisector, PM is the angle bisector, ray PM is the angle bisector of angle P. Second example, this is a figure and here values are given PM, PQ, PR and NR's value, and if I want to prove it, NM is parallel to QR. Here I am going to use the converse of BPT. If I want to use the converse of BPT, I should have the ratio. These two ratios should be equal. PN upon NR is equal to PM upon MQ. So first I will find out the PN's value and MQ's value. So PN's value is PR minus NR. PR is 20 minus NR is 8, that means answer is 12. Here I will find out the MQ. PQ minus PM. PQ's value is given 25, here it is 50, that means answer is 10. Now we will take the ratio PN upon NR. What is PN? PN is 12, NR is 8. If you reduce it, you will get 4 3s are 12, 4 2s are 8. So this is the first equation. Similarly, we will take the another side's ratio PM upon MQ. PM upon MQ is equal to 15 upon MQ is 10. So again you will get, if you reduce it by 5, you will get 3 upon 2. So from 1 and 2, Pn upon Nr is equal to Pm upon Nq. Pn upon Nr is equal to Pm upon Nq. So I can say that Nm is parallel to Qr. What is the reason for it? Converse of BPT. So here, therefore, Nm parallel to QR. What is the reason? Converse of BPT. Third example, triangle MPN, MN is given 5, PN is given 7, MQ is given 2.5. I will write these values over here. MQ is 2.5, MN is 5, PN is 7, and they have said that NQ is a angle bisector of angle N. So here solution, segment QN is angle bisector of angle N. Therefore, by property of angle bisector, you can get it Nm upon Np is equal to Qm upon Qp. If I start from Nm, then another ratios I have to start take it from Mq upon Qp or Qm upon Qp. What are the values? Mn is given 5, Np is 7 is equal to Qm is 2.5 upon Qp. Qp, it is unknown, we have to find out, it is x. If you do the cross multiplication of these two, you will get 5x, 5 multiplied by x is equal to 7 multiplied by 2.5. 7 multiplied by 2.5. X is equal to 7 multiplied by 2.5. 5 is in multiplication, if you take it over there, so it will go for the division. So x is equal to 2.5 you can divide by 5. So 5 ones are, and here 0.5 will come. And 7 multiplied by 0.5, answer will come 3.5 units. So therefore, QP's answer, therefore QP is equal to 3.5 units. Fourth example, figure is given. In this B angle is 60 degree, that is given, and we have to prove that AP upon PB is equal to AP upon QC. Like this ratio we have seen in the PPT theorem. So if I want to use the PPT theorem, if I want to prove this by using PPT, I have to prove it that PQ should be parallel with the BC. Now for that, to prove the PQ parallel with the BC, the information is given that angle P means angle APQ and angle ABC is 60 degree. So here if you observe, these are the corresponding angles, and by using corresponding angle test I can prove PQ is parallel with the BC. So let's see. Solution: angle APQ is congruent with angle ABC. So what is it? This looks like a corresponding angles. If these two are corresponding angles, then therefore segment PQ is parallel with segment BC by corresponding angle test. This we have studied last year. Now if these two sides are parallel, then therefore by BPT, Basic Proportionality Theorem, fifth example. In this fifth example, AB is parallel with PQ, PQ is parallel with CD. So, solution: by property of three parallel sides and transversal, we can get it AP upon PD is equal to BQ upon QC. So what is AP? AP is 15, PD is 12, is equal to BQ. BQ we have to find out upon QC is 14. After this, just transfer 14 on this side. So 15 upon 12, if you transfer 14 on this side, so it is in multiplication is equal to x. 12, 14 is divisible by 2. So 2 6 are 2 7 are. 6 and 15 again divisible by 3. So 3 2s are 3 5s are. So here you will get 5 7s are 35 upon 2 is equal to x. Therefore x value would be 17.5 units. Sixth example, in this triangle M and P, we have to find out QP. Here they have given this NQ is an angle bisector. If it is an angle bisector, then we are going to use by property of an angle bisector. What the property says? NM upon NP, NM upon NP is equal to NQ upon QP. NM is 25, NP is 40 is equal to 40 upon Q. Here I'll use the variable x. Do the cross multiplication. After cross multiplying, 25 multiplied by x is equal to 14 multiplied by 40. Transfer this 25 on this side. We will get x is equal to 14 multiplied by 40 upon 25. Now 40 and 25 are the divisible by 5. So 5 5s are 5 8s are. So here you will get 14 8s are 112. So x is equal to 112. 14 8s are 112 and divided by 5, and if you divide it you will get 5 2s are 10, 5 2s are 12, 25.22.4 units. Therefore, QP is equal to 22.4 units. Seventh example. In this example, they have said that AB is parallel with CD and is parallel with EF, and we have to find out the value of X. So here AB is parallel with CD is parallel with EF. So therefore, by the property of three parallel lines and its transversal, property of three parallel sides and its transversal, what is the property says? BD upon DF is equal to AC upon CE. Put the values. 8 upon 4 is equal to 12 upon X. Here these two are divisible by 4. So 4 2s are 4 1s are 2 upon 1 is equal to 12 upon X. Transfer X on this side. So 2X is equal to 12. By 2 you can divide this 12. So here you will get X is equal to 12, transfer on that side. So 12 upon 2, that means X value would be 6 units. This is X value. They said you to find out AE. What is AE? AE is equal to AC plus CE. AC is 12 plus 6, that means answer is 18 units. Eighth example, LMN triangle MAMT is an angle bisector of angle M, and here the values of LM is given 6, MN 10 and TN is 8. Now we have to find out the value of LT. So solution by property of an angle bisector What is the property says? LM, I have started from here, LM upon MN is equal to LT upon TN. LT upon TN. Put the values. LM is 6, MN 10, LT we have to find out, it is X unknown, TN is 8. These two are divisible by 2. So 2 3s are 2 5s are, and transfer 8 is on this side. So 3 upon 5. 8 is in division. If it will come here, multiplication is equal to X. 8 3s are 24 upon 5 is equal to X. So X is equal to 24 upon 5. So if you divide it, you will get the answer. X is equal to 5 4s are 20.4.8. So what is X? X is LT. Therefore, LT is equal to 4.8 units. Ninth example, ABC triangle. In this, BD is an angle bisector. Solution. Therefore, by property of an angle bisector, What the property says that AB upon BC, AB upon BC is equal to AD upon BC. Here BC's value is given x plus y. Put the values. AB is x, BC is given x plus 5 is equal to AD x minus 2 and here x plus 2. I'll put them in the bracket. Now cross multiply. So x multiply by with this bracket. So x multiply by x plus 2 is equal to, it will transfer on that side. So x minus 2 into x plus 5. Here multiply inside the bracket, you will get x square plus 2x is equal to. Now here you have to multiply this bracket one by one. So first I will multiply this by x, means x multiply by x, 2 multiply by x. So x multiply by x, x square. These two multiplication would be minus 2x. Then these 5, by 5 I am going to multiply now. So I will first multiply by with the x, then I will multiply with 2. So here I will get the plus 5x minus 10. So in this side x square plus 2x, on that side x square. What about them? These are the like terms, you can subtract it. So here you will get 3x minus 10. X square on both the sides, it will be cancelled. It will left 2x is equal to 3x minus 10. 3x transfer it on this side, 2x plus it will come on this side, minus 3x is equal to minus 10. Here minus x is equal to minus 10, therefore x is equal to 10. So what is the value of x? X is equal to 10. 10th example, this is activity based example. So in this, activity is given on page number 15. You can go through it. Now here you see they have considered in triangle XDE. They said that PQ is parallel with DE. PQ is parallel, PQ is parallel with DE. And they ask the reason, that is, what is the reason for it? It is a given. Now next, if it is parallel, then by BPT, what you can get it? Here, if you observe this triangle, so here you will get XP upon DP by BPT theorem, XQ is equal to QE. So XP upon DP is equal to XQ upon QE. What is the reason for it? It is a basic proportionality theorem, that means BPT. Here, another triangle, a triangle XEF QR is parallel with EF. Again, what is the reason? Given. If it is parallel, QR is parallel with EF, then by given, so by BPT, you can get XQ upon QE is equal to XR upon RF. So I'll write XR upon RF is equal to XQ upon QE. So what is the reason for this? This is the second example and by BPT. Reason is BPT. Now from 1 and 2, if you observe, so RHS, XQ upon QE, XQ upon QE. If these two are equal, then of course from 1 and 2, this is the first equation. So from 1 and 2, you will get XP upon DP is equal to XR upon RF. Check it. XP upon DP means this ratio of this triangle, XR upon RF. So here this is applicable for the third triangle DXF. So therefore by converse of BPT, you can say that PR is parallel to DF. What is the reason? Converse of BP. And hence it is proved. 11th example, in this they have said that triangle ABC. This is a triangle ABC. They said that BD bisect angle ABC. So BD. So here there is a ray BD bisect angle ABC. Same way ray CE. From C there is ray CE. So here these are the angle bisector. Here also these are the angle bisector. So you will get these two angles and these two angles are equal. And here they said that segment AB is congruent with segment AC. What we have to prove? That we have to prove ED is parallel with BC. So B here BD and here CE. So here ED is parallel with BC. ED is parallel with BC. That I have to prove it. That means I have to join this ED. So proof: BD is an angle bisector so what will you get the ratio? AB upon BC is equal to AD upon BC. Check the ratio, just CE, hide this CE, you will get AB upon BC. So what is angle bisector? So it makes the opposite sides, these two part. So AD upon BC. So this is the first equation. So what is the reason for this? Property of angle bisector. Similarly, second, here I have considered BD is an angle bisector. Now, if I consider CE is an angle bisector, I will get another ratio. What is the ratio from C? So here AC upon BC. AC upon BC is equal to, on another side, it divides in the ratio AE upon EB. Now students, see, in given AB and AC are equal. AB and AC are equal. All denominators are already same. So AC and AB are equal. So here this AC, but AB is equal to AC. So instead of AC, I will write AB. So here AB upon BC. What I have done here? AC is equal to AB. So instead of AC, I have written AB. BC as it is equal to AE upon BE, and I'll consider this is equation 2. Again, if you observe from 1 and 2, LHS of these two equations are equal. So therefore, from 1 and 2, AD upon DC is equal to AE upon EB. Now if you observe AD upon DC, so AE upon EB. So it looks like a BPT theorem. So by converse of BPT, therefore by converse of BPT, you can say that ED is parallel to BC. Hence it is proved. Students, in this way we have finished the practice set 1.2, which is based on the angle bisector and BPT theorem and then converse of it. Students, please don't forget to subscribe this channel. Thank you.